For these three problems, we're told what is combining and asked to determine what salt would be formed from these ions. Our process here is much the same as moving from the name to the formula. Easier even in this first case because we're given the ions with their charges. First, rewrite your ions in the correct order, cation, then anion. Exchange the charge on the cation for the subscript on the anion, and then the charge on the anion for the subscript on the cation. Things to look out for include the implied 1 on this sulfate. Remember not to write that in. The more important trick here is the use of parentheses around the ammonia. Since we will need two 1+ cations to balance the single 2- anion, and since that cation is a grouping of atoms, we will need to denote there are two of them by placing the subscripts on the outside of a set of parentheses. Here we're given the names of elements, so we first have to determine what type of ion each element would make. Calcium is found in the second column of the periodic table. This is the column that can most easily get to a noble gas electron configuration by losing 2 electrons and forming a 2+ cation. Oxygen is found in group 6 and will gain 2 electrons to form a 2- anion. Reviewing our ions, we see that they are the same magnitude, both 2. This gives us the same number of positive charges and negative charges just as is, and we will only need one of each ion. If you can't logic that out in your head, no worries. You can just do the swappy chargy thing. You'll just need to remember that we always write our ionic compounds in the smallest version of whatever ratio you come up with. For instance, here we come up with a ratio of 2 calcium ions to 2 oxide ions. We can reduce that to 1 calcium ion to 1 oxide ion. This means that our formula isn't Ca2O2, but really is CaO. The last one gives us the names of the ions, so we have to come up with the formulas and the charges for them. The barium ion is a monatomic main group ion, so it will always adopt the same charge, which is 2+. The nitrate anion is one of our polyatomic ions, and it has the formula of NO3 and a -1 charge. In reviewing the charges, we can see that barium is twice as large in magnitude as the nitrate. In order to get the same number of positive and negative charges, we will have to double the number of nitrate ions present. Since nitrate is a polyatomic ion, and since we will need more than one of them, we'll have to remember to place that nitrate group in a set of parentheses prior to adding that subscript of 2.